Okay, we're live. So we're going to do lesson 9.3, but before we do that, we're going to go through these examples here on example 7. Oh, hang on. One more thing. Okay, there we go. Fixed problem. All right, let's go through these. I kind of gave you a couple of ways to do it. I think the easiest is to just make a sketch, right? So let's make a sketch. What two numbers make 0 on the number line? Well, if x is -2 and if x is 2, you get zeros. So those are the points that are the boundaries of my inequality here, right? But can they be those numbers? Can x be 2? Well, no, because if x was 2, this would be 0 is less than 0. So what does that tell me about the dots I'm going to make? Means they got to be open. Now, is the answer going to be this line between the dots, or is it going to be the areas on the sides of the dots? I don't know that, so I'm going to do a test point to find out. And my test point is going to be 0. So I'm going to test 0. So 0 plus 2 is 2. 0 minus 2 is -2. Is 2 times -2 less than 0? Sure is. So that's my answer. There. So I found my answer. Now I just have to write my answer symbolically. Okay? And you know what? When I did this lesson yesterday morning, so you guys were the morning class, so you should have been watching the video in the morning, right? Or watching the Teams meeting in the morning. You know what I forgot to mention, I forgot to say completely, is that you can do this with interval notation if you like interval notation better. So let's do both answers here. If I was going to do this in set notation, I could say my solution is x is greater than -2, but less than 2, right? It's a continuous line, so you can write it as one statement, right? If it's two separate lines that don't touch each other, that aren't continuous, then you have to use two x statements. But there we go. So there's the solution. That's the answer. If you don't want that, though, you could put this in interval notation. What would this look like in interval notation? Well, it's just going to go -2, 2. What kind of brackets would you use, though? They have to be curved. How come they have to be curved? Because these are open dots, right? X can't be -2 or 2. So put them in curve. Now, how do you know that that's an answer and not a like just a coordinate or something? So usually what you do is you put x and then a colon. That tells the person reading it, oh, those aren't, he doesn't mean coordinates there. He means that's the two numbers x can be for a solution. And, sorry, that's the two numbers that bound the x solution. So that's an interval notation. So either one of those is a perfectly fine answer. I'm good with both. Usually when you're doing inequalities, though, you stick to an inequality set notation. But there's nothing wrong with doing it in interval notation, too. Okay? All right, let's do the next one. First of all, this one doesn't give me my boundary points. I got to find them by factoring. So that's going to be what two numbers times to make -20 and add to make -1. That's going to be -5 and +4. So that means I have boundaries at 5 and -4. So I'm going to make my sketch. So we go all the way to -4, 3, 2, 1, 0, 1, 2, 3, 4, 5. Okay, what kind of dots can I use this time? Solid, because those two numbers are answers, right? If you put in a 5 here, you get 0 is greater than or equal to 0. Well, 0 does equal 0, so 5 counts and -4 counts. But is the answer to the left and right, or is it in the middle? I always test 0, so 0 minus 0 minus 20 is greater than or equal to 0. Is that a true statement? That is not a true statement. -20 is not greater than or equal to 0. So that means the answer is going this way and this way. Okay, I can't put this as one statement, right? It would be wrong to say x has to be greater than 5 and less than -4 at the same time. It looks like I can say that, but you're not allowed to use set notation that way, right? You're only allowed to make it into one statement if it's a continuous line. Because think about what you're saying. You're actually saying that there are numbers that are bigger than 5 and smaller than -4 at the same time. Good luck at finding such numbers. They don't exist. So you can't write it that way. You have to write it as two statements. X is less than or equal to -4. I like to use a comma. X is greater than or equal to 5. Now, that's the answer I would use. If you'd rather use set notation, you can, but it's a little more complicated now, right? Because you'd have to say you go from -infinity up to -4, and then you have to put a solid bracket, okay? And if you can put a comma again between the two sets of brackets, or sometimes people use this symbol. It means basically, it's called union, because it's like a big capital U. And it actually means together with. So together with 5 to infinity. So either of those is good. I don't really care which way you do it. Again, most textbooks, since it is inequalities, they'll use set notation and inequalities for the answer. Okay, any questions on how I'm doing it so far? Guys at home, we all good? I've got my eye on the chat. If anybody has any questions, let me know. Okay, the most common mistake people make with C is they forget the main rule of how to solve quadratics. And they start trying to think of, which two numbers times to make -6? And they try to factor x squared plus 5. You can factor that, right? You could factor out an x, but that's not the way to do it, right? What's the first rule of solving a quadratic equation? You get all of the constants, variables, and coefficients and everything onto one side, right? So I'm going to get all the terms to one side by adding, and now I'm going to factor again. So let's see, this guy factors. What two numbers times to make 6 add to make 5? I think it's 2 and 3, right? And okay, so my boundaries are -2 and -3. Now, this hasn't happened to us yet. There's -3, there's -2, there's -1. They're both open circles, right? Because it's a greater than. There's no whole numbers between those two numbers. So what would you do? You know what? I'm still going to test 0 because it's just easier to work with. But what am I expecting? Well, let's see. Well, let's see if 0 works. So I'm going to test 0. And when I test 0, I go to the original equation too when you do that. I get 0 plus 0 is greater than -6. Is that true? Yeah, it's true. Now I know, so that means it's going that way. It's going to go to 0 and include 0 in its answer. I know that parabolas are symmetrical. But you know what? It might be in a bad habit to train myself to always just go there, then it must be the other arm. I know it's the other arm. Haha. Because you will eventually have to do these interval kind of notations and these interval kind of diagrams for things far more complicated than parabolas. In fact, that's going to happen to us next semester when we're doing intro calc. We do stuff that's much more complicated than parabolas. So let's just make double sure that the other intervals are true, right? I'm assuming that this arm is going to go to the left now, right? But I haven't actually proved that. All I've proved is that 0 is an answer. Let's do another test. Let's test -4. And all we really care about is -4 going to make a number smaller than -3? So in other words, is it going to make this thing true? Well, that would make us a negative times a negative. So let's see. If I test -4, what happens? So that's going to be -4 squared is 16. So this is a negative times a negative, right? I don't even care what the number is. If I put -4 in here, I get a negative. If I put -4 in there, I get a negative. What's a negative times a negative going to be? Positive. Aren't all positives greater than 0? Yeah. So that's true. It works. So we're going that way. Okay. Now, if you wanted to actually prove that the middle part doesn't have any answers, you could pick a number between -3 and -2. You'd have to pick a fraction. But okay, if you had a fraction, if you had -2 point something, doesn't it make this guy negative and that guy positive? And what's a negative times a positive? Are negatives bigger than 0? No, so it fails. So there's no answers between these dots. Okay? So you have to use your logic and your reasoning powers to make sure you have the right answer. But there's the right answer. Now what is it? There's the diagram of it. What is it in symbols? I would say x is less than -3 and x is greater than -2. That's the way I'd like the answer, but if you prefer interval notation, you'd say you go from negative infinity to negative 3 together with negative 2 to infinity. Both good. Okay, and then just for one more fun one here, there's a tougher one to factor. You could use decomposition on it if you want, but I think I can see it. I know 2x squared really only breaks to 2x squared, or 2x and x. And I'm going to have to get to 5. Well, 5 is actually 1 less than 6, and I know 2 times 3 is 6, so I think there's my winner. 2 times negative 3 is negative 6. Negative 6 plus 1 is 5. So there we go, we got it. And that's less than or equal to 0. So that means x is negative 1/2, and x is 3. So let's put that on a number line, see what happens. There's negative 1, 0, 1, 2, 3. Okay, so what kind of dots do I have? At negative 1/2, I have a solid dot. And at positive 3, I have another solid dot. Oh, you know what? I already drew the line. I honestly don't know if that's the line yet. Dot. Okay, let's test 0. Does 0 make this group work here? Let's see. 0 minus 3 is less than or equal to 0. That's a true statement. So, yep. There we have it. And to put that into symbols, x is greater than or equal to negative 1, but it's less than or equal to 3. Okay, and if you put it in interval notation, my x values are from negative 1 to 3. Oh, sometimes instead of putting an x here, when people are writing things in interval notation, they'll use a capital D. What do you think that stands for? Domain, right, because those are the x answers. Yep. Negative 1. Oh, yeah, thank you. Duh. Thank you. You're far more awake than I am. That's a mistake. That's a half, isn't it? I have hot coffee. I have cold coffee. Still, I have not had enough caffeine to stay awake. That's bad. There we go. Ta-da. Okay, there we go. So that was the 4 things I gave you for homework. Hopefully, any questions about them? All right. Let's go and let's just finish up then kind of our last kind of lesson. And really, it's just kind of a continuation of what we were doing. What if we have a quadratic inequality in 2 variables? So in 2 variables, we're going to get something like this. So we have to graph this on a grid because we can't just use a number line because we have to be in 2 directions, the x directions and the y directions. And we're going to shrink that a bit. And first of all, we're going to graph the boundary, right? So let's graph the boundary. The boundary is graphed at y equals negative 2 times x minus 3 squared plus 1. Okay, we've graphed parabolas lots. It has a vertex of 3, 1. So 1, 2, 3, 1. There we go. What else do I know about it? Well, I can actually find its x-intercepts if I wanted to, or I can just count, right? Let's just count this one. This negative 2 means that I move over 1, and instead of the usual go down 1, if it was 1x squared, because it's 2x squared, I go down 2, 2 times 1. So 1 over 2 down. So there's a point. 1 over 2 down, there's another point. A normal parabola would go 2 over and 4 down if it was negative 1 for an a value. So this is going to be negative 2, or negative 4 times 2. So that's negative 8. So 2 over, and then 8 down. So there's 6, 7, 8. And then 1, 2, 1, 2. There we go. That's all the points that I'm going to fit. And okay, what kind of a line should I have? I guess I kind of just gave it away. It's dotted, right? Because that doesn't have an equals under it. Right? Right here, for those of you who no equals under that. So I'm going to graph this as dotted, 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 dotted. Now, which region is the answer? It can't be anything on the line, but it's either all of the stuff outside the parabola or it's all of the stuff inside the parabola. How do I figure that out? I am going to test the point 0, 0. If it's true, if it makes a true statement, then it's everything outside the parabola. If it makes a false statement, the answer is everything inside the parabola. So 0 is less than negative 2 times 0 minus 3 squared plus 1. Is that a true statement? 0 is less than negative 2 times 9, which is negative 18 plus 1. 0 is less than negative 17. Is that a true statement? It is quite false. Therefore, the correct answer is shade inside my parabola. And again, I never went to kindergarten. I don't color very good. There we go. All the points in that purple zone are part of the answer. And of course, the purple zone gets bigger, bigger forever. Any questions on how I did that? Okay, your turn. You give that one a try. And I'll catch up to you. So here's what we'll do. For the people in the room, I freeze the projector. For the people at home, I'll just pause. Well, the people at home watching live, I will unshare my screen for a minute. And for the people watching on video, I'll just pause the video for a sec. There we go. We're back. Did you get that? Or something that looks very close to it? Okay, let me run through how I got my answer. The first thing I did, let me highlight what I'm saying. First thing I did is I noticed, well, I have a y-intercept of 6. So put that down, right? So that's the first thing I did. Second thing I did was I thought, you know what, I should have a vertex if I'm going to make a reasonably accurate graph. And just to mix it up, I haven't used this in a while, I used the minus b over 2a trick. So minus 5 over 2 times 1 is negative 5 halves. And then, of course, to get the other coordinate of the vertex, you have to run negative 5 halves through the equation. So 5 halves squared is 25 fourths. 5 times 5 halves is negative 25 halves. And that'd be negative 50 quarters plus 25 quarters is negative 25 quarters plus 6, which is 24 quarters. So I got a y-coordinate of my vertex of negative a quarter. So there's how I got my vertex. So 2.5 to the left and a quarter down. So that's how I got those numbers. Okay, so that was the vertex. Then I decided, you know what, I kind of want more than just those 2 points. So I counted this point by realizing whatever distance horizontally this point is from the vertex, then the one on the other side has to be the same. So I just counted that point using symmetry. Then I decided, let's get some x-intercepts because they're easy to find. Right? How do you know right away x-intercepts are easy to find? As soon as you realize you can factor your quadratic. So I factored the quadratic and found that my x-intercepts are negative 3, negative 2. So there's the 5 points I used to get my quadratic. Quadratic done. Did I know what kind of line to make? Yep, solid line, right? Because it's a greater than or equal to. So the numbers on the line are part of the solution. Then lastly, I have to figure out which region to shade. So I tested 0, 0. And it turned out 0 is greater than or equal to 6, which is a lie. Yep. Shouldn't I do what? But, oh, whoops. Yeah, you're right. Why did I do that? I realized that it was a lie, then I shaded the wrong side. Wow, I don't know why I did that. There, let's fix that. So we are shading the part that doesn't include 0, 0, which is, again, inside the parabola. Look at that. Thanks for noticing that I goofed that up. There we go. Oh, I went outside the line there. Sorry. Okay, so there we go. And I think that's it, right? That's all the examples in the notes. Everything after that is some practice. So today you can work on these practice questions. I'll pick a few that I like. Again, from the workbook, I'm not going to assign a whole bunch. I'll just pick some ones that are good, that are you know, would practice the kind of stuff that you'd see on a quiz. We'll quiz this stuff next week. It has, the pages in the booklet now have an answer key, except, looks like page 18 maybe doesn't have a key. Let me look. Does page 18 have a key later? That page has a key someplace. There's a review there. Practice problems. I think there's a key for the review and the practice problems, isn't there? Maybe not. Yeah, there we go. This is this page. What page is this key for? Is this page 18's key? Yeah. So page, oh, that's page 19's key. Looks like page 18 needs a key. So we'll have to get you a key for page 18. Page 16 has its own key. All right, so page 16 has a key. 17 is the key for 16 and 15. Page 18 doesn't look like it has a key. Page 19 and 20 and 21. Do they all have keys? And 22. There's the key for 18. There's the key for page. Yeah, that's it. Okay, so it looks like there's only one page in here that doesn't have a key, so I'll have to get that for you. But there we go. That's your assignment. I'll put that onto the blog that you're going to work today on the rest of the booklet, and then I'll pick a few questions from the workbook to add to that. Okay, so that's the lesson for today. I'll stop the video. Guys at home, you have the choice. Okay, I'll stop the video.